Bismillahirrahmanirrahim. In this session, we will discuss about the symmetry and for O-level and IGCSE student under the subject of mathematics. And here we have line symmetry. A line symmetry divide a shape into two identical parts. Suppose this shape, this is a triangle, right angle triangle, and if we have a line symmetry, so if we have a line and we fold it and we have this shape and these shapes are similar, so this is called a symmetry. So it creates a symmetry. Similarly, if we have this kind of shape, the rectangle has two lines of symmetry. So this lines, if we fold, this point will fold on this point and this vertex will fold on this one. So and similarly this edge will fold on this edge, and this edge will fold on this one, and similarly this part will fold on this. Similarly, if we fold across this line of symmetry, so this is called symmetries. So let's solve this exercise 3.1. For each shape, write down the number of lines of symmetry. Here this is a line of symmetry. Similarly, this has a zero line of symmetry. If we have this line, when we fold it will be here or it will be here. So this is zero line symmetry. We cannot develop a symmetry, and neither in x-axis or on y-axis. So this is not symmetry. And here if we divide this line and if we fold it from here, because it's an equilateral triangle, if we fold across this line of symmetry or if we fold across this line of symmetry, so there are three lines of symmetry: this one, and this one. So these three lines of symmetry. And similarly, copy and complete each pattern so that Z L is a line of symmetry. So if this is a line of symmetry, this is a line of symmetry, and we have to complete it. So let's solve this. And rotational symmetry after that, so we will discuss it. And for the question number 1, we have this 4 line of symmetry. For this this line of symmetry 1, second line of symmetry, third line of symmetry, and this fourth line of symmetry for square shape. For this parallelogram, 0 lines of symmetries exist. For this equilateral triangle, 3 lines of symmetries exist. And for this shape, we have this given this shape, and we have to create a symmetry. So we have this shape here, and this other shape will appear here. So this creates this across this line symmetry. This is across this symmetry by shaping this and this. So this is once we fold, we have this portion on this and this portion here. Similarly, this one here. So this will have a symmetry. Similarly, this line of length, we have this information and we have to complete a symmetry. So this is completing a symmetry. It will shape like this. It will create a symmetry. So this is important. So if we have this, then this should be here. If this is here, so this should be here, like this. If this shape is here, then this shape should be here. If this shape is here, then this should be here. So this is called symmetry, because this is the line of symmetry we have considered. And similarly for this shape, if we have this shape and we have this portion, then this should be like this. So we have created this shape like this, here to here, and then this one. And similarly for this shape, we have this created this shape and then this one. So this across this line of symmetry, this will be same. Similarly for this shape, we have this created this shape, and for this shape we have created this shape. So this will across this line of symmetry and this line of symmetry, because this here we have 2 lines of symmetries, here we have 2 lines of symmetries. Before that we have only single line of symmetry. Now we have 4 lines of symmetries. So it will be this one be reflected here, and this will be reflected here, this will be reflected here. So this is 2 lines of symmetries. That's why this LL and MM. Similarly for this, we have this shape. from this symmetry to this. So this is 31.2, a rotational symmetry. So we'll discuss the rotational symmetry. This shape has a rotational symmetry of order 3 about 0, because if we shape here, this will here and this will here. So it will rotate and will have a similar shape in 3 different positions. So these are 3 positional where the shape fits onto the original shape in one complete turn about the center. So this is rotational symmetry. The order of rotational symmetry is the number of times that a shape fits onto itself in one complete turn. This shape has no rotational symmetry. This shape has no rotational symmetry. It will again appear on this, so we'll have this. So at any other position, this is it is not possible. So this, it has rotational symmetry of order 1, because it will rotate and again appear in this original form. So this order of rotational symmetry is 1. So while this shape has an order of rotational symmetry is 3, because this, if we change here and change here, so at 3 points, at this point, second and third, we have this rotational symmetry. So let's solve this. And 31.2, and we have this given, and we have to find a rotational symmetry of order 2. So for solution, so these shapes are given, and so this rotational symmetry, so this should be order of 2. So once it rotates 180 degree, this will be same. This point will be here and this will be here, and after that this. So this is order 2 rotational symmetry. So this order 2 rotational symmetry, because this was missing, so we have created it, and this will give this rotational symmetry of order 2. So this is a tricky one, so this is not easy. Similarly for this one, we have given this information and we have an order of 4. So this should be like this. So if this shape 90 degree, if we turn it to the 90 degree, then this side will be like this. In this line or this shape, if we rotate it to 90 degree, then this will again be appear as with this one, and again if we rotate 90 degree further, then this will again appear like this. If we rotate it for another quarter, then we will have the same shape, and after that for the 4th quarter we will have again the same shape. So this gives a 4th order symmetry. So for rotational symmetry of order 4th, this shape should have this kind of feature. So this is a difficult one, not an easy one. No symmetry but rotational symmetry of order 2. So the symmetry is not agree, but rotational symmetry of order 2. If we rotate is half, if we rotate 180 degree, this shape will be same, but otherwise we cannot rotate. At this point we rotate, shift or add across this line, there is no symmetry, but the symmetry of rotational symmetry is of order 2. This, for rotational symmetry of order 2, we should have this one. So this will again appear, if on 180 degree shift, it will appear like this. So this is important. So next we will discuss exercise 31.3 in the next session.